Have you ever stopped to think about how you'd count something that's, well, basically impossible to count? I'm talking about things like every possible password for your email, or every single move in a chess game. The numbers get so big, so fast, they're just astronomical. You could never, ever list them all out. So how do we even know how many there are? That right there is the counting problem.
All right, let's bring this down to earth for a second. Let's start small. Say you have 3 simple tasks to do, A, B, and C. How many different orders can you do them in? Seems pretty easy, right? And it is! You can just write them all out. ABC, ACB, BAC, you get the idea. There are exactly 6 ways. When the numbers are small like this, just listing everything out works perfectly fine, no problem at all. But what happens when we scale this up just a little bit? Forget 3 tasks. What about 10? 10 things you need to do today. How many different ways can you schedule your day? Take a wild guess. A few hundred? Maybe 1,000? The answer is over 3.6 million. That is just staggering. All of a sudden, our simple method of just listing them out is completely and utterly impossible. This is the counting problem, and it's a massive challenge in fields like computer science.
So to wrestle with these gigantic numbers, brute force just isn't going to cut it. We need a better way. We need a set of powerful mathematical shortcuts. We need a toolkit.
So here's our plan. First, we'll take a look inside that toolkit. Then we'll get to know its 2 most important tools, permutations and combinations. After that, we'll figure out how to choose the right one for the job. And finally, we'll see how all of this is used to build the tech we rely on every single day.
Okay, so let's pop open this toolkit. At its heart, you'll find 3 fundamental pillars for tackling these huge counting problems.
Now, it all starts with something called the multiplication rule. That's kind of the basic building block. But today, we're going to zero in on the 2 heavy hitters that build right on top of it, permutations and combinations. These are the powerful shortcuts we really need.
Let's grab our first tool. This is the permutation. And with permutations, you really only have to remember one thing. And I mean one thing. Order is everything. To really get a feel for this, let's use a simple analogy. Think about a smart lock on a door, or even just the passcode on your phone. And let's say the code is super simple, 1, 2, 3.
So you walk up and punch in 1, 2, 3. Click, the lock opens. Perfect. But what happens if you punch in 3, 2, 1? It fails. Buzzer sounds. Now think about that. You used the exact same numbers, but because you changed the order, you got a completely different result. That right there is the soul of a permutation.
So if we want to get formal about it, a permutation is simply any arrangement of items where the sequence is absolutely critical. Think passwords, the finishing order of a race, or scheduling tasks on a computer. The order defines the outcome. All right, time for our second tool, the combination. And if permutations are all about order, well, combinations are the complete opposite. Here, the only thing that matters is the final group you end up with. For this one, let's switch to our grocery cart analogy. You're at the store, you've got your list, and you need to grab 3 things, an apple, some bread, and milk. So does it really matter if you put the apple in the cart first, then the bread, or if you start with the milk? Of course not, right? When you get to the checkout line, you have the exact same 3 items. The order you selected them in made 0 difference to the final group in your cart. And that's a combination. It's a selection of items where the sequence is totally irrelevant. Think about picking players for a sports team or choosing which servers in a data center to update. It's all about the group you end up with, not how you got there.
So now we have our 2 tools, permutations, where order matters, and combinations, where it doesn't. The real power, the real skill, comes from knowing which one to use and when. That right there is the master key to solving any of these problems.
And honestly, it all boils down to one simple question you have to ask yourself every single time. Does changing the sequence change the outcome? If the answer is yes, like our smart lock, then you need a permutation. If the answer is no, like our grocery cart, then you need a combination. It's really that straightforward. This table is basically our cheat sheet. You can even look for key words when you're reading a problem. If you see words like arrange, schedule, order, or rank, that should set off alarm bells for a permutation. If you see words like select, choose, group, or team, you're probably looking at a combination. Oh, and check out that last row. For the same set of items, you'll always have way more permutations than combinations.
Which makes sense, right? Because every single different ordering counts as a whole new possibility.
So you might be thinking, okay, cool analogies, but why does any of this really matter outside of a math class? Well, it turns out these tools aren't just abstract theory. They are absolutely critical to how our entire digital world functions.
I mean, just take cryptography. Permutations help us calculate exactly how many possible passwords exist, which tells us how secure a system is. Or networking. These principles determine the number of unique IP addresses we can have. Literally, how many devices can connect to the internet. And think about a data center. Scheduling jobs on a computer processor is a permutation. The order is critical for efficiency. But just selecting a group of servers to get an update, that's a combination, because the order you pick them in doesn't matter at all.
So look, if you take one thing away from all of this, let it be this. Whenever you're faced with one of these big, scary counting problems, the very first thing you should do is just stop, take a breath, and ask that one simple question. Does order matter here? Your answer to that question is the key that unlocks the entire problem.
Now, there is one little catch. Everything we've talked about today assumes each item is unique and you can only use it once. But what happens when you can repeat things? You know, like on a license plate where you can have the same letter or number show up multiple times? Well, that opens up a whole new world of possibilities. And it's a puzzle for another time. Thanks for watching.